Nothing too interesting to report today. I didn't study too much, but what I did study is more on Boltzmann magnetization. So, the definition of Boltzmann magnetization is the equilibrium nuclear magnetism of a spin sample in a magnetic field. That's the definition of it. And Boltzmann magnetism is the sum of all the different magnetic moments when the equilibrium of the spin-up state specifically um, has lower energy than the spin-down state. Um, and you can go and get an equation for polarization, which is the excess number of spins that are aligned in the low energy state. So there's going to be a whole lot of protons with spin up and spin down, and for each spin up and the spin down, it cancels out each other. So you only have a very small amount that are actually detected. And I wrote down the equation for it. I don't need to pronounce it. But the expression for the Boltzmann magnetism is the magnetic moment times the number of spins in a sample, or the density, times the polarization. That's how you calculate it. Um, I I'm writing down the notes of pretty much exactly what I hear. I understand some of it, but there's definitely parts I'm missing. I think I'm just gonna finish the first entire video series, and then I'll probably write down my questions on something separate, and then look it up, or maybe just find a different lecture. I think I've said this before, but for some reason, you know what, since I think I've said before, I'm not even gonna bother saying it. I know I always get worried of, oh, if I don't say something, it won't be recorded, but I don't care. I know that I know this at this time, and I know this in the past, and I know that I've known this in the future. It's nothing important or new to talk about. Um, Everyone else, pretty much except one other person's leaving tomorrow to visit, so well, I mean, I'll still have the same amount of time since I'm gonna be going to job, but it should be more quiet at least.